In 11.2, we'll be talking about converting rectangular equations and polar equations. So we're going to start with the same 4 formulas that we used in the last set of notes. So with that right triangle, we were able to get the 4 formulas. X squared plus y squared equals r squared. Tangent of theta is y over x. X is r times cosine theta. And y is r times sine theta. So we're going to be using the same formulas that we used to convert their coordinates, to convert their equations as well. So we are going to start in this first section by converting polar to rectangular. Now, we know what rectangular equations often should look like, which makes this a little bit easier. For instance, if we end up with the equation of a line, it should be in the form of y equals mx plus b, although that's not the only way to write the equation of a line. If we end up with a parabola, we may have y equals x squared. You could also have x equals y squared. So just remembering how equations should look to get our final answer. If we end up with the equation of a circle, of course we want x squared plus y squared equals r squared, which is nice because that's actually one of our formulas, so we'll see that here. So our first example we're going to start with is r equals secant theta. So we probably have no idea what this looks like in its polar form. So by converting it, we can figure out what this is. Now, we don't have a formula that involves secant, so we're going to rewrite secant as cosine over cosine. Now what I need is r times cosine. This is from formula number 3 here. To make this work, I need r times cosine. So to make that happen, all I really need to do is multiply cosine on both sides. So now I have r times cosine is equal to 1. And now I can use my substitution, r times cosine for x. And I'm left with x equals 1. So I finally end up with my rectangular equation of x equals 1. And to draw this, well, this is just the line x equals 1. So a vertical line right here at 1. So let's try another example. This time we start with r is equal to sine theta. When it comes to sine theta, I need r times sine theta. Now, by moving sine over to the left, we won't be multiplying by sine. So in order to make this happen, I'm going to have to multiply both sides by r. So now you can see on the right side we have r times sine theta, which I can replace with y. But on the left, we still have r squared. So it's partially in polar and partially in rectangular. So we are going to use our first formula, which says that r squared is equal to x squared plus y squared. So we're going to make that substitution in here. And now I have x squared plus y squared is equal to y. So this is the form of a circle, although it's not, this equation in particular is not in its standard form for a circle. So we are going to have to get this equation into its standard form by completing the square. So we'll subtract y over. We'll leave room to complete the square. So we just have to figure out what number is it that we have to add here to make these y's factor nicely. So half of negative 1 squared makes 1/4. And now I can write my equation as x squared plus y minus 1/2 squared is equal to 1/4. And this is what our answer... Okay, sorry about that. So we're going to finish this example by drawing our circle here. So we have a circle with a center at 0, 1/2, and we have a radius of 1/2. So up here, we'll have a center of 1/2, and then we'll go in a radius of 1/2 in each direction. All right, so there's our picture to match our equations. So we're going to keep going. All right, number 3 just says r equals 2. Now this should be pretty obvious. This is simply telling us radius 2. So what we should have here, what we should end up with is a circle centered at the origin with a radius of 2 units. And so we should really be able to write this in rectangular coordinates very easily. So this is just x squared plus y squared is equal to 2 squared, or 4. So how do I get there? Simply by squaring both sides, we'll do the trick. So now I have r squared is equal to 4. And then again, I go back and I use formula number 1 here. And we're going to make this substitution of r squared is equal to x squared plus y squared. And that's how we would do this one. So it's a much cleaner example from number 2. So we have one more here that we're going to do for polar to rectangular. That says theta is equal to pi over 3. So the only formula we have here to get from theta without r is tangent. So we are going to introduce tangent to both sides. So notice tangent theta is equal to y over x. We'll introduce tangent to both sides. So we now have tangent of theta is equal to tangent of pi over 3. So we replace tangent of theta with y over x. And then we evaluate tangent of pi over 3, which is root 3. All right, so it's been converted, but this is not the typical way we would write an equation in rectangular form. So if I just move x over, I'm going to multiply x on both sides here, right? Then we end up here with y is equal to root 3x, or y equals mx plus b. So if you consider that in its point slope form, you do have the equation of a line. And so that's what this picture should be. So it's simply passing through the origin and has a slope of root 3. So that would be up root 3 and then over 1. And that would give you your slope. Now, you could also do this from the viewpoint of theta equals pi over 3. So all you have to do is no matter what r is, it's saying no matter what radius you start with, a radius of 1, a radius of root 3, a radius of pi, it doesn't matter. You're just going to make an angle of pi over 3 with the x-axis. And so you would create this line here, as well as any negative radius would also create this array on the other side. And so here is our line with a slope of root 3. The only thing we might not want to have in here are these little lines. So it's our picture. In this section of the notes, we're going to convert our rectangular coordinates or equations to polar. So this might seem a little more difficult because we're not used to the way that a polar equation should look, but you've seen some examples so far. Most of them have started with r equals. So typically we'll be aiming for getting our equations into this r equals format. There are a few times that you'll leave it as r squared equals, and then sometimes it'll even be a theta equals equation. So here on the next problem, y is equal to x squared. And we know what this is in rectangular form, the shape of a parabola. So let's go ahead and look at what it becomes in polar form. So what kind of things can we do to replace here? So we simply might just grab our formulas. So y can be replaced with r times sine theta, and x might be replaced with r times cosine theta. So I have r sine theta equals r squared cosine squared theta. And like I said, we usually want this to be in an r equals format. To get that, you would start by dividing both sides out by r. So now I only have sine theta is equal to r cosine squared theta. And again, if I want to get this r over here by itself, now I'm going to have to divide both sides by cosine squared. We don't usually like to leave our trig formulas as a fraction. So now we're also going to simplify what we have left. So I'm going to break up cosine squared into cosine times cosine and then regroup them. So sine over one of the cosines is tangent, and then the remaining 1 over cosine becomes secant. And then this is the way we like to leave our formulas. So r equals tangent times secant. It's not as nice as it is in rectangular form. All right, for number 6, I'm starting with 4xy is equal to 1. Now this is also not the way we typically write our equations in rectangular form. So really, if I were to write this in rectangular form, I would divide the 4x to the other side. So 1 over 4x. And it might be a little more obvious to you that that's a rational function now. But we're still focusing on just wanting to convert. So we're going to do the same thing as last time. X is r times cosine, y is r times sine, and you are left with equals to 1. So simplifying this here, we have 4r squared cosine sine is equal to 1. So let's aim for getting r squared by itself. That means we're going to divide everywhere by 4 cosine and sine. So I'm now left with r squared is equal to 1 over, and maybe you saw this, this pattern here. There's a 2 embedded in that 4, 2 times 2. And then I also have the sine and the cosine following. So remember that sine 2 theta is equal to 2 sine cosine. So if I just take one of those 2's along with my sine and my cosine, I can actually replace that with sine 2 theta, and then I just have a coefficient of 2 there. And then I can do even better than that and leave this 1/2 and bring sine to the numerator. So it becomes cosecant 2 theta. And then it wouldn't do us any good to square root both sides and leave it as the square root of 1/2 cosecant 2 theta. So we would, in this case, just leave this as r squared equals. So I did mention that there were times when we would leave it in terms of r squared. So this brings us to our last example. And it's a little bit of a mess. There's all sorts of stuff going on here. We could try to replace the x and the y with r cosine and r sine, but we would get stuck pretty quickly. That might still come into play in a little while, but really the only thing that's going to help here is a trick of adding y squared to both sides. So you'll see how this works nicely when we do this, but it's not so obvious from the beginning, adding y squared to both sides. So this helps on the left because x squared plus y squared is equal to r squared. So I'll get my substitution there. On the right side, what I'm going to be able to do is factor this. So this becomes y plus 2 squared. And that doesn't seem like it helps us much either. But at that point, I can make my substitution for y with r sine theta. So we're going to do all of that now in the next step. So you can see we have r squared is equal to y plus 2 squared. So again, it's partially converted and then not. So over here, we're going to go ahead and replace y with r sine theta. So we're left with plus 2 squared is equal to r squared. Okay, so what's nice? We want to get r by itself, and so we're going to square root both sides. And last time I said we don't want to do that. This time it's not so bad because we have both sides are squared. By square rooting both sides, it works out rather nice. So r is now plus or minus r sine theta plus 2. Okay, why do we have to do more? Because I can't answer r in terms of r. So we're going to split this apart and see what happens here. So I have r is equal to positive r sine theta plus 2. And over here, r is equal to negative r sine theta plus 2. So we have to fix this problem of there being too many r's. So let's start with the one on the left. So anytime I have multiple r's, the best thing I can do is get them alone on the same side of the equation. This allows me to factor it out. And then to get r alone again, we'll just divide 1 minus sine theta. And that's actually one of my equations. So the other side here, on the right, we're going to distribute our negative. And we're going to do the same thing. So I'm going to add r sine theta. We're left with equals negative 2. We're going to factor out r. 1 plus sign is left. And to finish here, we'll just divide 1 plus sine theta. All right, so now we have our 2 answers.